Okay, we good?
Yep.
Okay. So this week I will be talking about the GAIA benchmark. So this is something, just curious, has anyone heard of the GAIA benchmark already? No hands. Okay. Yeah, it's actually a little bit old. It was in 2023 and it's a very interesting set of tasks, but it never really took off. People didn't get that interested in it. But now we're getting smarter and smarter models and we're getting these better agentic systems. And so people have started taking more interest in it because initially, like if you have a task that's so hard and you can only get it right 3% of the time, it's just not very interesting to even approach it. It's just impossible. Um, so the big thing about the Gaia benchmark, the problem that they're trying to solve is there's lots of language model benchmarks. So they say, can you answer this fact? Can you do this math? But one of the big problems with it is a lot of them are very specific. So can you do the math problems? Can you do reading comprehension? Can you pass a medical exam? Like there's all of these sort of narrow things. And one of the problems with this is when you optimize for that small of a set, you can kind of game the metric. You say, okay, train on this kind of data, and then all of a sudden my model looks amazing. But in reality, it's not like the model got the intelligence of a doctor, it just got the information of a doctor. And so it can't necessarily do all of the reasoning and thinking that you would expect them to be able to. And so the Gaia benchmark is trying to build on top of this and say, like, well, what do you need to do in order to have more general intelligence? So one of the things is they want to be able to use tools kind of generically. So we just give you a question, and then you have a certain set of tools available to you. Can you compose them in order to answer this question correctly rather than just how good are you at doing web search or calling a certain function or fitting a certain format. Um, and so the whole purpose of this is to build a benchmark that just kind of generically measures this. How good is a system at doing usage of tools in multiple steps in order to solve kind of like assistant tasks? Um, so the Gaia benchmark is very small in relation to a lot of other systems that a lot of other benchmarks that we look at. So like MMLU and some of the other ones that you see on the score sheets a lot of the time might have 50,000 questions or it might have even more than that. And this one only has 466. So that seems like a very small sample size in terms of like measuring intelligence of something, but it's very diverse and it uses a lot of steps in order to. So an individual question might test you on seven different things all at the same time. So it's much more comprehensive. So across the bottom, we can see the different kinds of things that they're looking for in the certain questions. So of that 466, 355 are testing on its ability to browse the web. And so browsing the web on itself is kind of can be a sequence of tasks. You say, okay, I load this web page and then I look at the image on this page and then I have to do some reasoning about what's in this image. And then that might lead me to go somewhere else on the web. So the web browsing doesn't just mean I did a search. It's I had to kind of navigate and think about what is being presented back to me. And I'll show some examples of these questions in a second. But that's kind of the premise of this is so you might have to do some web browsing, you might have to do some coding, you might have to look at images, you might have to look at video. It's very, very open domain. Like it's just kind of here's a question, and then what are all of the steps needed in order to solve it? So this graph on the right is showing the distribution of the questions and the number of tools that need to be um, used. Yeah. So this one in the bottom right is showing the number of steps that were taken in order to complete this. So the way that they generated these questions is they had humans actually go and say, I want to answer this question. And then they say, okay, to get there, I went to this website and then I loaded this file and then I looked in the PDF and I saw there was a table that had, so they show like all of the steps broken down and how do they got to the specific answer that they got. And this makes it significantly harder to game because you have to go through all of these steps and you're interacting with the web, which can change. So you do a Google search and you might not get exactly the same result, or someone updated their website, or YouTube changed their layout, or there's all kinds of these things. So you can't just memorize the answer or know like this is the kind of thing that we're looking for. Um, so they have a split, so 166 validation that they give out to everyone. So you have, I know this is the question. I know these are the tools that they expect to be used. I know it's supposed to be this difficulty. It's probably going to take about this number of steps. And then the test set is like truly hidden. They just give you the prompt and then you can just submit to the leaderboard and get some feedback, but you don't know the tools and everything else that's supposed to be used. Um, so here's kind of the breakdown that they show. So just some examples of what they mean when they say web browsing. So it could be as simple as making a Google or a Bing search. It could be going to a website and filling out a form to do a different kind of search. So like one of the questions, it's going to a like chemical registry site where you say, I want a chemical that has this property and this property and this certain composition. And so it's all about just filling out the form. Um, they want you to be able to access YouTube. And one of the really complicated ones is looking at Google Street View. So it's saying, go to this specific location, look in this direction. What's the tallest building in this way? What does it say on their front sign? Like it's very complicated stuff like that, where your model has to be smart and it has to use the tools that it has available in order to kind of do all of these things together. So the web browsing is very heavily used, but it's a mixture of everything. So some of the questions could just be a CSV. They give you a file and it's a bunch of financial data, and then it says like, what's the average transaction price or something like that. So your agent has to write some code to load the file and look what's inside, and then it has to say, okay, here's how I would aggregate this in order to get the average transaction price. Um, so here's the breakdown of all of the different files that are passed to it. So a lot of them are Excel files, like I was just explaining. So they give you an Excel file, and then your agent's supposed to load it and see what's inside and do all the steps in order to answer whatever your question is. There's a lot of PNGs, so you have images and you have PDFs and you have text files and you even have MP3s. So they give you audio and then it has to do something with that audio. So you might have to build a tool that says, read this and say what the people are talking about or what kind of music is this. Like it's very, very open. You need like a generically smart system. Um, so looking at some of the examples, this is the starter prompt that they give you. So basically they're saying, we're going to give you a question and we want you to respond to it in this certain format. So it might be a string, it might be a number. It's always something short. So they're not expecting you to write an essay back. They just want you to give like, here's the number that I found. So like for in this one, they give you this file, this SLSX file, and they say, okay, go look at that and figure out how to get the total sales for these items. And so it has to look at the file, it loads it, and then it prints it out and it says, okay, here's all the columns that I have, and here's how I'm going to aggregate this. So you can see it's that this question is asking, what are the total sales that the chain made from food, not including drinks? So if you think about what it has to do, it has to look at the columns and then it has to say, okay, which of these are drinks, which of these are not drinks, and then subset based on that. And then it has to take the total. So it's loading in burgers, hot dogs, salads, fries, ice cream, all of these things that aren't drinks. And then it's saying take the sum of that and then format it so that it gets it in the format that they wanted. So they split these questions into three different levels. So level one is like maybe it only takes one or two steps, maybe it uses tools, maybe it doesn't. So these are not as difficult of questions. And then level two is something where it's like, okay, this might use multiple tools or it might use many steps. And level three is even harder, where it's saying you might have to go to multiple places to find information and combine it in some way, and you might have to use multiple different kinds of tools. So you might have to go to a website and load an image and check a file and do all of this stuff together in order to come to the final conclusion. So there's a breakdown of the different levels. It's a little bit arbitrary. They have some guidelines of level one has certain amount of steps or one or less tools, but they kind of just judged them by hand and said, this is a level one, this is a level two, this is a level three. Um, so then they benchmarked the systems. And so just for context, this is a paper from 2023. So these are the models that were available at the time. So they said, how often can you solve this just with a search engine? Not very often. How often can you solve it with GPT-4 by itself or GPT-4 Turbo? And then they also looked at Auto GPT-4, which is one of the original like agentic systems. So Auto GPT was supposed to be set up so that you can like give it a query and then it goes and works and works and works. And people were very excited about this at the time. And you can see it was useful. It got some more questions right than in the past, but in the end, it still wasn't that accurate. And then you compare that to GPT-4 with plugins. So a while ago, OpenAI created a system where everyone could write custom tools for ChatGPT to use. And they said basically when we add plugins, then the accuracy goes up significantly higher. But still, in context, the humans get like 92% correct. So it's still completely dwarfed. So we look at these systems and we say, wow, they are smarter than a doctor at these certain things. But then you look at the other aspect of this and you say, they can't even make a web search and find the right information that I'm asking of it. Um, so this really shows its ability to kind of do this step-by-step, simple series of tasks and look at the feedback it gets and make the correct decisions. Um, so this is a one comparing the scores based on different subsets. So this is looking at its ability to read different file types. And so by default, the GPT-4 on its own can't read these files at all. It just can't open them. It gets a CSV and then it's just dead. And so with Auto GPT-4, it could read it sometimes. And with the plugins, it obviously does a lot better because all of those plugins, there's probably a plugin for listening to audio and converting it to text. And there's probably a CSV converter and stuff like that. So with all the plugins, it's able to get much more. Um, this is the set for just kind of everything. This is web browsing. And so you can see with the plugins, it seems to do the best across the board. So this is what it looked like at current state when they originally made the benchmark. They just used the best models and the best agentic systems and everything. But now everything has progressed significantly beyond this. So we've kind of learned this is the kind of stuff that people want to do, and we've optimized these models. So if you look at O1 and O3 and Claude and all of these new models, they're significantly better at these kinds of things. And at the same time, people have built all of the tooling and kind of the frameworks in order to make them better at these kinds of things. Um, so this is a breakdown of the number of tools that were used for these different tasks. So you can see like if you used 6 tools, then it probably took about this amount of time. Like the amount of time goes up as you use more tools. And the same thing with the number of steps taken. So if you used a lot of steps, it probably took a long time to complete these tasks. And this is kind of an interesting way of quantifying how much time saving you might get from using these things. So imagine you have a task that takes 40 steps and the model is actually able to complete it. That might save you 15 minutes. And even if it takes 30 minutes for the system to find that, that's 15 minutes that the computer is working and you're not working. So that's still useful, even if it takes extra work for the system in order to get to those conclusions. And so here's a look at what the data looks like. So this is an example of one of the questions. This specific question doesn't have any files. It's a level one because it's one of the more simple ones. And on the validation set, this is what I was talking about. They kind of give you the trace of what actions did the human do in order to complete this thing. So they searched NIH, they clicked the top link, and then they went through this whole process. And so in the end, they used 8 steps. It took them 8 minutes, and their final answer was 90. So we have this data for the validation set, but we only have the original question for the test set. So this can kind of function as a guide, but it's really just to kind of look back and understand what the path was in order to get the correct answer. So that's all I have for slides, but one of the things that I've been working on this side, I'm doing some of this stuff for work, and so one of the things I was trying to understand is like we have this system that's solving these prompts. Um, what is it doing right? What is it doing wrong? And so I built this little viewer tool so that I can just kind of say like, our model's working through this. Is it taking the correct steps? Where is it failing? Like, what is it bad at? Um, so there's a lot of interesting ones in here. Let me pick a. So like this one, for example, this might be a little small, but basically what the question is asking is it wants you to find all of the fractions that use a slash instead of numerator over denominator. So just looking at what this image looks like, it's basically saying, look at this file and find all of the fractions that have like the slash like this, versus these ones that are like 6/8 instead of 6 divided by 8. So the difficulty with this is a lot of these systems, if you go to GPT-4, it didn't have vision by default, so you have to go to some other tool that says, look at this page and understand what's on here. And then the second thing is it needs to kind of capture that fine-grained difference between, like, if you just throw this to an OCR system, it might represent 1 divided by 4 is the same as 1/4. And so you need something that's rich enough to actually look at it and understand the difference. So this is actually one of the simpler questions, but you can see how it kind of composes multiple different pieces of looking at it visually and then getting something back to the language model. Um, so this one is kind of funny. It's saying if there's anything that doesn't make sense in the instructions, write the word pineapple. Do not answer any of the questions in this prompt. Write only the word guava. So the intention is it wants you to just write the word guava. It wants you to ignore all of this other stuff. But then it also gives you a list of questions, hoping that you ignore them, saying, what is 4 + 4? There's another question, what is the complementary color of red? How many hours are there in a day? And then our system goes back and forth and makes a plan, basically. So it starts with a thinking portion where it's basically saying, make a plan of how you would solve this. And you can see it saying, okay, I might use this tool. I might have to run some code. I might not have to run some code. Okay, there's multiple questions here. How do I do this? So this whole portion is just kind of doing a planning step. Um, and then you can see it starts writing code. It's figuring out this problem. It's saying, oh, you want me to calculate 4 + 4. You want to calculate hours in a day, but it's kind of funny because it just sets this as the answer. It doesn't actually calculate anything for that. And then it's wrote a function, find complementary color, and it just says the complementary color is green. It's not actually calculating anything. And then it realizes, oh, wait, I'm supposed to just say guava. And then our system goes back and forth and it realizes, okay, I just say guava, but then our system is like, no, you didn't try hard enough. And so it just the model keeps saying guava and our system keeps kicking it back, saying, no, try harder, guava, 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 guava. So this is why you need to look at your data and understand what is your model doing, because in the end, this is getting the correct answer. So it expects it to just return guava, but the model gets it, but it did all of this extra work because it's just not very smart. So we learned things from looking at the data and understanding what went wrong. Um, so yeah, I have a lot of these that we could talk about, but I think I'll stop there. There's a lot of interesting ones that I've kind of plugged through and learned about. So that's Gaia benchmark. This time I don't have any like technique or anything to teach you guys, just to show you Gaia exists. It's this interesting benchmark where you can test these sort of agentic systems and see how they do.
Awesome. Thanks, Ryan. Questions for Ryan?
Do they go into any sort of, do they have any possible explanation for why it gets caught not logically?
So that's kind of just the scaffolding of our agent is like trying to enforce it to look for like verify its answer. So our system itself puts a constraint on the model and says, like, keep trying, double check your answer. And so that's just our own system telling the model to keep going because it doesn't want it to exit early and be like, oh, I can just answer this in one word rather than like going and verifying and making sure it's getting the correct answer.
What made it go off in the first place from those parameter sets? Because it was trying to give an answer at first.
Yeah. I mean, that's just the skill of the model. It got tripped up by, oh, I have all of these questions to answer, and it said piece this together, and then it realized, oh, actually, it said don't do any of this, and so that's just the model itself, not being able to correctly follow the directions at first, but then realizing later, okay, I was given this instruction, I should follow this one. This is the most important.
Like a teacher who puts on a test, don't answer any of the questions, just write 42.
Yeah.
And then part of the instructions are read all the instructions before you answer any of the questions. You get to the end, the last questions, don't answer any of them.
Then, that's my one slot. So do they put like slot only for the final answer, or they put slot for kind of like which step you take and each step?
It's only for the final answer. So that's part of the like beauty of it is you can get to the correct answer a lot of different ways, but all they care about is that you got the final result correct. I couldn't hear that totally. Good.
The take into the storage. What would actually like pass the tree is that or more? But in sometimes I kind of sacrifice some of the levels so that we have as a training and
So yeah. So the question is like if we trained with the known steps, then wouldn't it reach the conclusion faster? Um, so that is possible, but you need a lot more diversity and more of these available in order to get that. So if we trained on this, like we only have 166 in the validation that we have the known steps and the final result for. So if you only have 165 questions, that's not a very diverse set. If you trained on that, you're probably not learning the general like how to use your tools and how to react to different errors and all kinds of stuff like that. So part of what you're trying to bake into the models is its ability to handle, oh, I got this error, or I didn't get the search that I expected, or this thing timed out. Like what do I do to handle that? That's part of the like resilience of the system because it's not always going to get the perfect search and the top link is the one that it wants. And so you need to kind of bake in like its ability to wander and recover and get to the correct answer.
And I don't know if I just couldn't see it on the slide, but I think for the ground truth on the astronaut, it said the answer should be given in the form of last name, semicolon, number of minutes with a common 1,000 separator. I think the ground truth didn't have the common. So there's also a validation, potentially. You can run a situation where you're telling it to answer something that's giving you the correct answer, but your ground truth's the problem.
Yeah. So one of the struggles with this data set is it's heavily reliant on the internet, and the internet is constantly changing. So we've gone through and validated a lot of the questions, and some of them are unsolvable at this point. Like they point to someone's YouTube channel and it says, look in their banner and see what the symbol is that, and they change their banner, or the YouTube account doesn't exist anymore and stuff like that. So there's a lot of like, after looking at these problems, there's a lot of issues with it, but it's still kind of like directionally correct.
I'm curious, so you said that this was sort of like that Gaia was an old, or
Old in relative terms is from 2023.
okay.
Yeah.
Well,
Yeah.
Has it become more popular because of agentic systems becoming more popular? Is it being like what led you to decide to use, like, say, Gaia as opposed to like maybe some other alternatives?
There are some other options, but I think this is one of the most holistic ways of evaluating like how smart a model is at doing generic tasks. There's some other ones, I forgot what it was called. It was like humanities last exam or something like that. And that one's good too, but we focused on Gaia first. Just because we can't do everything at once. But yeah.
So is there any like downside or notable downside that you saw with the humanities last exam, which has the best things?
I haven't looked at that one as much as this one, so I don't have any opinion on that.
Sure.
Yeah.
All right, great. Any other questions? Any questions online? I'm having trouble loading my chat for some reason, so I apologize if someone typed a question there. You could just unmute.
I did have one more question. I was a meeting on Thursday, and there was a Google developer that was examining DeepSeek as well. And the GRPO methodology he was actually reading that as one of the great assets of its reasoning processes. But he also mentioned that what DeepSeek did too, as well is, and I don't know if everybody does this in terms of training their model, but they were using a lot of synthetic data because there's so much that you can just get from the internet, right? In your opinion, do you think that like essentially using synthetic data allows it to synthesize its reasoning even more to engage in higher levels of conclusions that it's available currently on the internet?
Yeah. I'll repeat the question for people online. So it's a question focusing on like, is it possible that synthetic data could push the model to have better reasoning and better capability? So that's something that my company's been looking at, is like we have this limitation of this data set only has 166 examples, but we looked at it and we realized like we could make a bunch of these. We could just send a model and say, go to random websites and find random files and kind of make up questions and go figure stuff out. And then we can kind of train the model on that, all of the generated ones, and that can kind of flex its muscles, saying like, get more consistent at surfing the web and get more consistent at looking at images and using the right tools and everything like that. So I think that's a promising direction. I think that that's where a lot of the promise is, but we'll see. I'm sure that's one of the GRPO stuff. It's nice because you can kind of just generically say like, give it a score. You don't have to give it the full path. And so if we can kind of generate those, I think that that would be a good way to make something that's easily verifiable that we can pass back to GRPO.
So it's almost like the GRPO and the synthetic data have a reciprocal compounded effect, because now it's like being able to synthetic create its own playground
Hmm.
in order to train itself more on a particular task.
Yeah. Yeah.
That's
Yeah. Yeah.
Question, if what you're using is an agentic system and you have a trace that says do these 10 steps, it's not completely transparent and obvious to me how you would train the system with that information. Can you comment on that?
Well, that's the value of the GRPO is you have to say just optimize for a certain outcome. And you're not saying at the token level, okay, do more of this, do less of that. And you also have to mask off the sections that are returned by your code coming back or your web search or something like that, because that's not something that the model gets a choice in. So you just have to optimize the parts where it's saying, like, make this web search so it can consistently point to the right thing. It's a little bit, I haven't seen someone do it yet. That's what I'm trying to figure out. So,
Yeah.
but
Would it be mostly trying to optimize the planner agent, not really the worker agents?
it would still be the same for us. We only have a single model, so it's the whole thing is planned by an individual model and acted out by the individual model. um so it would be the optimization of both, hopefully.
Okay,
But
yeah, I was just thinking
yeah.
generically, sometimes people have
Yeah.
different planner. Yeah, maybe that's heavier, but the one that does searches or the other things.
Yeah, yeah. What we've found so far is that a lot of people have done those sort of multi-agent systems where it's like, here's my coding agent, and here's my planning agent, and here's my reasoning agent. What we've found is you just want the smartest model in every spot, and you just tell it what you want it to do. So in reality, having separate agents just kind of muddies the water, because then they don't have the complete context, and you might not be using the absolute smartest at every piece. But that's other people are using different approaches, so it's not like the final answer.
Is there anything like a pre-processor or pre-classifier going on that says, hey, this is information that I need to analyze and summarize versus information that I should look this up from somewhere?
Yeah, so the question is if there's any like preprocessor going on, kind of classifying what it should be doing. Um, not in this system, but I'm sure that there are some that's happening. So in our system, we give it access to various different tools, and one of the tools is just a like reasoning piece. So you basically say, okay, go into reasoning mode, and here's the prompt, and make a plan, or format the answer, make sure that it follows all of the directions and stuff like that. So we don't have an explicit pre-processing step or anything going on there, but it we have modules that the model can choose to use whenever it sees fit.
Does it try multiple modules, try to relate the answers to each other and see if they're in agreement versus you have to a third module and see if that one is the tiebreaker?
One of the things that we've done is we allow it to do multiple runs and then take consensus, but it's separate runs. It's not looking at each other and saying, oh, I can verify your answer. It's totally separate trajectories, and then just looking and seeing, okay, if two of them are this answer and one of them are this answer, then it goes for the one that has two. But it's not doing any like smart combination of them.
For the ones, how is the randomization done to determine that, hey, I'm not going to take the same path each time through this. So if I'm reading the same search 3 times, I'm essentially just cutting 3 times the work for the exact same answer.
That's only controlled by just the temperature of the model. So the model is itself is just choosing its own path. It has nothing in the way of promoting diversity. Yeah. Yeah.
All right, great. Thanks, Ryan. Appreciate the discussion. All right, we're gonna switch gears a bit here for the second part today. So this will be a more participatory portion, and I need to figure out the logistics. So I can throw up the PowerPoint. Do you want me to flip this around and or you can sit here and explain the problems, walk people through the problems? Is that how you want to do it?
Do you have like a YouTube channel? Sorry, just a browser. There is a link I'd like to paste on the browser.
Uh,
Just explain what's a question. We go to my actually, how about yeah, this will work. And
All right.
then in the slide, I actually already pasted in the
Okay, hold on.
comments.
I don't know if I'm showing comments. Trying to remember how do I don't think.
Notes and comments.
Oh, here. There, sorry.
Okay, sound.
Yeah, one sec. All right, so you want me to play this for everybody?
It will explain what's the probability question I was going to ask.
All right. All right. I think I got the logistics here. One second. So I'm going to share my screen. All right. So hopefully you guys see this YouTube and I don't know if my chat's working, but give me a shout if for some reason the audio does not come through or the video does not come through. All right. One other change I need to make locally. Sorry. The hybrid logistics are a bit of a pain in the neck.
So let's pay attention to how do they, anyone, all of you watched this before?
I'm on the second episode.
Okay, so just observe how this moderator is trying to tell the two parties to play the game. Now explain what's the question. Just switch back to the slide.
Okay.
Yeah. Sorry, I think the YouTube video is more do a better job so you can present this. So two people are going to play rock, paper, scissors. They're going to use two hands to show two hands at the same time. And then they observe what each other's both hands. They take one back, use the remaining to compete which one wins. So what is the probability that both parties end up as a tie in round one?
Random or rational actor?
Huh?
Random or rational actor?
I mean, the assumption here.
Rocks.
The assumption here is you want to win at whatever cost you can. I think the tricky is you have to think about, okay, I saw my opposing party's hands. Which hand should I put like stay here in order to win? Because you already see what's on the opposing party. You have to take it back.
Yeah, 1 in 18.
All right. So the point here is we're going to give you guys time to think about this. If you have a device or scratch paper, to go ahead and think about this a little bit. So the idea is right, not just to like have people pop up in his, just like Ryan was saying with his agent, right? It's not just 1/5. Like no, like actually, like let's go think about this and so we'll kind of get a sense for the room. Like we'll start with, I don't know, a few minutes, 5 minutes, give people some time if you want to discuss with your neighbor, or if you want to just do some scratch work. Okay. So the game is rock, paper, scissors. Okay. Hopefully everybody knows that part of it. Okay. Except unlike normal rock, paper, scissors, you're doing two simultaneous rock, paper, scissors, one with each hand. That's the first part. Then the second part is you get to see what the other person has done for their two. So they're corresponding, right? Right. You know, these two. And then you get to take one of your hands back. And so your remaining hand competes with your opponent's remaining hand, and you're trying to win. So what are the odds that somebody wins? What are the odds that there's a tie? And the question specifically says, what's the probability of a tie?
But tie on the first round. Of the
Yeah,
two hands.
yeah,
When you take it.
right. In the completed round, when you take it back and you see with one remaining hand, uh, who's the winner? Yeah. So let's just demonstrate it one more time here. The people on Zoom won't be able to see us. Yeah. Okay. So I'm gonna say rock, paper, scissors, go. Okay. Rock, paper, scissors, go. All right. So there's two of them. Now, on three, no, on three, I'm gonna say, take back one of your hands. One, no, don't think. Just do it. 1, 2, 3. Take back one. All right. Now who wins? Okay. That's the game. Yes.
We get a tie.
I could have decided to do this. And
Yeah.
Either of you could have taken back either one, but you can't change your hand.
But you have to think really quickly.
Yeah.
Okay.
Yeah. Yes. So now that I don't think that these guys in the poor video, I don't know what show that is. They didn't have time to really think this through, but you guys get a chance to think through what's the optimal strategy. What do you try to do? All right, we'll take like about a few minutes, about 5 minutes initially, and see if people are ready or if they want more time.
You have rock and paper that.
Yeah, well, they have, they even have.
Okay.
So.
All right, yeah. So we talked about one part of the strategy is should you throw two of the same thing at the beginning of the game? And now we're talking about like different cases. Let me just ask a question. When you're looking at the initial people playing the game and they throw two symbols, do you need to consider the case where I throw a rock with my left hand and a scissor with my right hand as different from if I throw a scissor with my left hand and a rock with my right? Does order matter for either player? Is there okay? So I heard a lot of nopes in the room. Does somebody want to make an argument for yes, it does? Yeah.
So seeing as like, I have never actually played the game this way before. I'm just thinking like
You are.
I'm thinking about like shoots. Right. That in absence
Yeah.
I'm probably going to get shot at something. So,
Right. But in the optimal strategy, if we're trying to analyze it, does order matter?
So that's the thing, like, at the end of the day, there's only two hands, right? So, if at the end, the outcome of just playing with one hand is 1/3, wouldn't that be the same for the outcome of using two hands?
I don't know if you guys could hear. So the question is, if we know the odds of a tie is 1/3 in regular rock, paper, scissors, are we destined to get the same answer in this variant of the game? And I think that the thing to consider is like the Monty Hall problem. Okay. Is there being information injected into the system? And there's clearly an opportunity for information to be added to the system because you get to see the other person's two symbols before you decide which to take back. So the classic case is the first one that Tony mentioned. So if your opponent has played two rocks and you have a paper and scissors, any rational actor would say, I'm going to pull back the scissors and keep the rock. So it's no longer random which of those two you pull back. If you saw that they had two rocks and you have one of your hands is paper and the other one's anything else. Yeah, no. So the setup was that you're playing to win. Yeah. I actually was thinking there's another thing is can you coordinate to play to tie? To postpone. If you think help's on the way, can you postpone and tie as long as possible? But that's a different strategy. The setup was you're playing to win. So again, that's my point that I think the answer, if you assume people are playing to win and have had time to work out their optimal strategy, is a different answer than if you just have people playing more randomly. Yeah. All right. Anybody want to add another piece? So, yes, please, Anastasia.
So basically, we have this situation that first player throw rock, paper, and second throw paper and scissors. And in any case, like the probability for like to have the same figures to have a tie is about 1/4 because the probability for first player to choose paper in this situation is half because he has two choices, either paper and rock. Either paper or rock. And then the second player has the same like, paper and different scissors. So the second player has to choose between two. So the probability of choosing the same to have a tie is 50%. So we basically need like 50 and 50. So in terms of probability theory, it's 1/4.
Okay. So hold on. So I think people closer to me, the mic will pick up, but I don't think they're. So I'm going to try and repeat back what you said. So assuming that both players do not play identical on both of their hands, then there's two scenarios. One scenario is that I play two things and the other person plays the same two things. What's the other scenario where we don't play the same two things? There's one in common and one not in common, right? But because there's only three total symbols, there has to always be one in common. Okay. Now you said. Okay. So you said the odds that people that the two players both have the same two symbols, you said is 1/4. I'm not sure I agree with that number. I think 1/4 would be considering order matters. Okay, no. I'm gonna stop you. So we're gonna keep going on this. We're not talking about the answer. We're just talking about what are the odds that two people throw the same two symbols versus one in common, but the other ones are different. Okay. And if order mattered, then maybe it would be something along the lines of 1, 4, 6. Okay, yeah. All right.
So can I get two hand rounds? Two people. Okay, I'll count 1, 2, 3. You show at the same time. Let's play 10 rounds and count. Can you count which one wins more? Okay, you count which one and you count which. Okay, really quick. 1, 2, 3. No count. No count. Okay, I count 1, 2, 3, and at 3 you show you show a hand and pull it. Okay. 1, 2, 3, go. 1, 2, 3.
All right, sorry again.
Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. It's already 5 times. How many? Okay. Do you want to keep? Okay, so we basically know how the logic works. Maybe the next slide.
All right, so then go to the one after. Oops, sorry. I want to hide this silly window.
Yeah. Probably.
Come on, how do you make this go away?
Oh, you can track this to the plan. Just track this.
Yeah.
Okay, cool.
It's
So
gonna-
my answer is a little bit different from ChatGPT, but I'll walk you through how that gets answered. So what I think about is I will think backwards because my question is what is the probability tie? So I'll start with walk. So assuming the result is walk, we have 2 players. And we can switch player A and player B's result later, but bear with me. In order to get a walk, assuming player A gets 2 rocks,
Sorry, it's covering part of the screen. I just cannot stop this. I don't know how to make this thing go away.
So assuming the result is walk, and then player A goes to rock. I know you mentioned that it's not a good strategy, but just assuming randomly, those player A goes to rock. Player B, it's fine for player B to have rock because it doesn't make sense. For player B, it's okay to have rock and scissor because this person will definitely pull back scissor. There's no way this person will keep scissor. There's no way for player B to have rock and paper because if I see my opponent is having rock, I would like to keep the paper. There's no way I want to take my paper back. So that's why this scenario will never happen.
Versus paper.
Scissor paper we'll talk about later. So
Against rock versus paper.
yeah, and at the same time, like the left hand, right hand doesn't matter. If this one equals to this one, the same thing. This is the first scenario.
Yes, so if I could paraphrase, you're enumerating situations that will result in a tie.
Yes.
Okay, so she's not covering all possible situations. She's just covering the situations that can lead to a tie.
Right. So going back to my equation here, we're going to switch player and player B's results in the final step. I know that player A is not only one who can play rock. So for the first situation here in 1 to 3 rows here, the probability for A is 1 out of 3, 1 out of 3 for both hands. The second person, there's 2 situations, 1 out of 3, 2 out of 3, because for the second player B here, of course, this person can do rock, can do scissors, and that's why for the first situation, it's 2 out of 81. So similarly, in order to get a tie for scissor, player A can go with scissor, and then the opponent can also do scissor, take it back, one hand back, still scissor. But for scissor and rock, this situation will never happen because imagine you have scissor and rock. There's no way I'm going to take back this one. Actually, I'm going to take it back this one because I want to win. I will keep this rock. So this second scenario would never happen. The paper, of course, I'm going to take back my paper because I don't want to get cut. That's why this scenario, scissors instead of paper, this combination will also work. That's why the second scenario, third scenario.
So wait, how are you getting your 1/3 and 2/3 in the far right column?
So you choose one out of three options randomly. Like when I'm thinking about the first trial, I don't really have a good strategy. Should I give paper or should I give scissors? It's out one out of three. That's why it's one out of three. This left hand, right hand, it doesn't matter actually. Left hand, right hand doesn't matter really. And that you have the second scenario.
But where does the 2/3, like just the top row, where does the 2/3 come from?
It's coming from, you can either choose scissors or paper. You have two options. It doesn't matter which hand, but you have two options. In order to get a scissor as a result, think backward. The question is, what is the probability of getting tie? So the tie, I'm assuming is scissor. You think backward, what are the combinations of the two players?
Okay.
Here and here, here A and here B. And three nothing compare, you are not wrong. At the I think there's over.
And to that question, I think this R is this 1/3, this R is this 1/3, this R is this 1/3, and then 2/3 is for the R versus S.
Yeah, yep.
Yeah, but it's kind of like for player B, it is to player B, and there is.
I haven't gone that step. I promise those two players, the result could switch.
Yeah, but then you are overcoming the arcs. The two arcs is yeah, I think the same one.
But there are two people, right? I'm talking. So we have two players.
I will over that are on both sides. That's the same. That's the same case between player and
Okay, so I want to see where you're going. So let's let her actually finish the explanation before we yeah. Yep.
I'll come back to the question. So for the paper, if we're getting a tie here, similar logics, the paper scissor will never have the combination because there's no way I'm going to, if I already have a paper, I want to keep my scissor here. So same situation, the only difference here is that I have a 2 multiply all those results because assuming that this portion could be here, this portion could be here. Now coming back to your question, RR and RR, the reason I would do 2 times because it's 2 people. I'm assuming that my 2 rocks are different from your 2 rocks.
Okay.
So we're both doing rock, you're doing rock. And I will multiply 2 is because I think you and me, we are 2 unique people. That's why I multiply 2.
Okay, but if you just take these 3 scenarios you have and you reverse them, then all of your scenarios include somebody having 2 of the same symbol. You don't have the cases where there's a rock paper and a paper scissor and nobody has 2 of the same thing.
Say it again. Okay.
Yeah. So if you did rock paper, okay, and I did, let's say, paper scissor, that's not anywhere amongst all your possibilities.
You're working backwards from only results right now that have the same outcome.
The tie.
And that's what I'm saying is that if she has rock paper and I have paper scissor, we can result in a tie if we both pull back other than the rock.
But if that's the case, in order for me to win,
There's also rock, scissors, and paper,
If I-
scissors, and
yeah,
rock,
if I
scissors,
want to
rock,
win-
scissors.
But it's symmetrical.
I
Yeah,
want
if there's
to.
2 of the same.
Yeah, but like rock, scissors.
If
paper,
this is the
scissors,
combination, should I pull back my paper or what?
But if.
So it actually depends, right?
Okay. So if you leave the Just one you want to.
If you-
want to go.
Yeah, if you pull back paper, you're guaranteed not to lose, right?
Can you do?
So if you do rock and scissors, and if you
So
pull
then
back
I
paper,
do
you're
this
guaranteed
results
not
at
to
a
lose
time.
because rock is gonna either tie with rock or it's gonna
Right.
be.
Gotcha.
So there are more tie scenarios.
So,
So your dominant strategy is to pull back.
but for him, for you,
For him, it's actually dependent, right?
so you could choose.
It actually,
either
he
one.
actually has to use his own risk profile and then decide.
Okay, so you can choose either scissors or paper. Okay,
So it depends on if I know what your strategy is.
I consider that rock, scissors, and paper, scissors is a tie, because if the other person has paper, scissors, right? They're not going to, take away, well, I guess, you know, if you're, they can take away either.
Again, it's based on risk.
Then again, you know, they do have a gun to their heads.
Yes.
I think it's like happened 2 out of 3 times. Yeah, if you're not having
that's true. I don't
Again, that's where the
consider the
strategy will come in.
combination of what you're
Yeah.
talking about. So I have a paper note here.
Yeah, but if
And you have a paper there, but you don't have paper, scissors,
Yeah,
or
if
rock,
you had,
scissors.
but you also don't have like paper, rock, and paper.
Gotcha. Can you go to the next slide? So,
That's what I was actually wondering, if there's a next slide with the other sample space.
so this is ChatGPT's result.
Yeah.
It's 5 out of 20, which is higher than my result.
Yeah.
Which could be the scenario that you were talking about.
So I think one thing though that might be I haven't seen your, oh wait, maybe this hides that stupid thing. Okay. I haven't read this ChatGPT solution, but I think it's looking at players playing random strategy, which is a different answer from I was answer players trying to play optimal strategy. Okay. So I think you do get slightly different answers.
So that's the assumption I made at the beginning. I was asking, like, if someone is playing randomly, like, the solution is just to enumerate all outcomes and understand, like, exactly what would win. But there is also a dominant strategy, as she mentioned, if you do end up playing specific hands, right?
Yeah. So going back to an earlier point, we were talking about if nobody's going to play 2 of the same thing, what are the odds that we have the same 2 things versus we have one thing in common and one thing not in common? So I would agree with that. It's 1 and 3 because since order doesn't matter, it's 3 choose 2, right? Which is also because you're leaving 1 out. It's also the same thing as 3 choose 1. Okay, so you just 1/3 you're leaving which one out, and so then what are the odds that my 1/3 equals your 1/3, right? So there's 9 scenarios of which one you leave out. You can count up the ones you keep, but then it's just more bookkeeping. So if you keep up track the ones you leave out, there's 9 scenarios for which one I left out and which one you left out, and 3 of them they will match. So 3 out of the 9, 1/3. And so from what we were talking about just a minute ago, if we have 1 in common, then if we keep those, we'll tie for sure. Okay. One of the players, it's symmetric. One of the players will have a symbol that will beat the thing in common. And one of the players will have a symbol that will lose to the thing in common. Okay. I don't think there is a dominant strategy. So you talked about a dominant strategy.
Dominant strategy. So if you have rock and paper and then the other person has rock and scissors.
Yes.
Based on whether you're risk averse or not, there is a dominant strategy of what would work for you to avoid loss, right? Because if you want to take back, let's say like I'm playing with rock and paper and you're playing with rock and scissors, right?
Yeah.
Rock and scissors. So in this case, right, like if I take back paper, I avoid any chance of, I might tie with you, but I avoid any chance of losing.
Okay.
Whereas if I take this back, then based on what you're taking back, I have a half chance of losing or a half chance of winning, right?
But that's
so based on
the perception.
Yes.
not necessarily because it's based on the hand that's not rock, right? So from her perspective, if she takes that back, she's either going to tie or she's going to lose to me. right?
But in that reason, she will have no reason to take away the system.
Exactly. So
Exactly.
like,
So
but
then you will
but-
always tie
yeah,
when you have one symbol in common if you play by that strategy.
well, it depends again on like risk appetite. If someone's trying to play someone else, then it's different, but yeah, that would be.
You know what's funny? If the bullet didn't have replacement every time, that would actually yeah. Yeah, do you want that? Do you want to take that chance earlier, or do you want to wait? There's like a billion.
I guess.
Also, if you're playing me, just assume that there's like 9 things in that sample space. Like, there's,
All right.
there's duplicates, there's duplicates.
So I'm not sure if we've come to a conclusion on the exact answer, but I think that we've done a good job exploring the combinatorics and the
More question. For more likely or less likely to have ties?
Less likely.
I think it could be more likely.
more or less than what? Than vanilla?
Yeah.
I think you're far more likely to have ties.
It depends.
It actually increases from 1/3 to like. What?
So
Yeah.
the
So
way.
the answer is
No, I think ChatGPT is wrong. I think if you play randomly, it will work out to still exactly 1/3. If you play randomly, completely randomly, I think it's still 1/3. Because then basically it's as if the one you took back never happened. You're just doing it randomly. There's no information added.
I asked
That's like
ChatGPT originally, and it just gave me the random. And then I said, assume that you're playing optimal state, and now it says 100%, which I don't think
It's not 100%, no. But for the random, did it come up with 1/3, or did it actually give you a different answer like 55?
It gave me 62%.
Yeah, I don't think either of those is right.
So I thought that like say.
All right, do we want to show the second one, or?
I don't know.
Yeah, I mean, we definitely won't have time for a whole thing, but if you want, you could just like show people and they could think about it on their own, or. Okay. All right. So the room is still going crazy with people trying to solve this. I think we're gonna wrap things up here. I hope you guys enjoyed that, and then maybe go on Slack if you think you have a good explanation of one of two things. You can speak to why you think a certain strategy is optimal or better, okay? And then you can also speak to what are the probabilities following any particular strategy pi. All right, so just to recap, next week we're doing book club. The week after that, a case study.
Actually, like, that's fair.
In 3 weeks, another book club, and tentatively we're gonna have a social event, not in the afternoon, but later at like happy hour, like 4 p.m. So thanks again for joining us, and we'll see you guys next week.
1/2 are dogs. Yeah.